Okay, so yesterday we talked about arithmetic sequences and series. And remember, it's arithmetic if you have a common difference that you add or subtract every time to get to the next term in your sequence. Okay? A geometric has a common ratio. That means you multiply or divide by the same number. So obviously, if you're dividing by the same number, your common ratio will be a fraction. Okay? So your common ratio, we call that little r. You know, like common difference yesterday, we had a little d. Well, common ratio, we have a little r. And that is the number that gets multiplied by every single time. So these first few that you have, and this is like the very first few on your homework today, gives you a sequence, and they ask you, is it a geometric sequence? Now, it's a geometric sequence if you multiply or divide by the same number every time. So what you want to do is take the second term and divide it by the first term. So what's 30 divided by 2?
15.
And then test another one by doing the third one.
15, 450.
Yeah, so is 450 divided by 30 also 15? Yes. Is 6,750 divided by 450 also 15?
Yes.
It is. So that's just double checking to make sure you are multiplying by 15 every time. So yes, this one is geometric, and the common ratio is 15.
Okay. The bottom one is yes.
All right. Initially it's no. All right. So the next one goes from 625, 125, 25, 5, 1. Notice that the numbers are getting smaller every time, right? So if it's getting smaller every time, that means if it is geometric, then the common ratio is a fraction. Okay? So let's do 625 divided by 125. I did that backwards. It's supposed to be second divided by first. My sorry. That's 1/5, isn't it? Is 25 over 125 1/5? Is 5 over 25 1/5? Is 1 divided by 5 1/5? Yes. So these are all multiplied by 1/5. So yes, it's geometric with your common ratio being 1/5. Okay. So if they're getting smaller from left to right, then your common ratio is a fraction. Does that make sense? Multiplying by 1/5 is the same thing as dividing by what number? 5. So that's why it looks like dividing by 5, because you are. All right, so look at the last one. It's going up every time. But you got to check it by doing top divided by bottom, or second divided by top, or second divided by first, sorry. 10 over 4, and we want to see if that's the same ratio as 18 over 10, and then so forth. So what's 10 divided by 4 reduced to? 5 over 2? Is this also 5 over 2? Is 18 over 10 5 over 2? No, it's 9 over 2. So these don't have a common ratio, so is this a geometric series or sequence? No, it's not geometric. So it is geometric if you're multiplying by the same common ratio or dividing by the same, which would be multiplying by a fraction. So you're all okay with telling whether if you have a geometric series or not. You have to multiply. Arithmetic, remember you had to add or subtract. Geometric, you have to multiply or divide. Okay. All right, here's our rule. So yesterday we had a rule for arithmetic sequences. It was a sub n equals a sub 1 plus n minus 1 times d. Remember that from yesterday? That's arithmetic. Today we have one for geometric. So for a geometric sequence, it's a sub n equals a sub 1. Now what does a sub 1 mean? The what?
What we're doing by, like, the fifth or...
Yeah, a sub 1 is the first term,
yeah.
Right? So a sub 1 means the starting term times r, and we said little r is our common ratio. That's the number we're multiplying by every time. And then n minus 1. N is the number term we have. So yes, we need to memorize that formula. My class, you're going to see that formula on your quiz tomorrow. You're going to have to be able to regurgitate that formula, I should say. So make sure you have it memorized. Uh-huh. That's up to Miss Durant. I don't know.
So the n minus 1 being the exponent, like exponent.
It's an exponent to the r, yes. Okay. So they start us with a sequence here. And they want us to write a rule and then find a sub 7. That means the 7th term. So remember from yesterday, when we're writing a rule, we leave n's alone. Okay, so we're going to use the formula a sub n equals a sub 1 times r to the n minus 1. But we're going to leave the n's as n's. So that means we're going to need the first term and the common ratio. Does that make sense? We're going to leave n's alone. So all we can put in is the first term, which is a sub 1, and little r, which is the common ratio. So how do you think we find the common ratio? Second divided by first. So 12 divided by 3 equals what? 4. So that's my common ratio. R equals 4. And what's my a sub 1? 3. What does a sub 1 mean? It's the first term.
So a to the n.
A sub n equals
a to the third equals 3.
3 times 4 to the n minus 1. You leave n's alone. And we can't do anything with this 1 because we don't know what n is.
Joseph Cook, come to the office. Joseph Cook.
So this is my rule right here. This is my rule. So your rule is when you have nothing but n's left. Now they want me to find a sub 7. That means they want me to find the 7th term in that series. So I'm going to come over here to the side. A sub 7 means I'm going to take this rule, and everywhere there's an n, I'm going to put a 7. So 3 times 4 to the 7 minus 1. All right, any questions on what I did there? I'd already written my rule. So I just substituted all my n's with 7s. And what is 7 minus 1?
6.
So a sub 7 equals 3 times 4 to the 6th power. Now, order of operations matters. You do not say 3 times 4 equals 12, even though it does equal 12. But we don't do that. Exponents come before you multiply, right? Okay, so you're going to do 4 to the 6th power and then times 3. Okay, now we can use our calculators. So 4 root times 6, you can hit enter, and then you hit times 3. And if you're good at using your parentheses and stuff, you could have typed it all straight in to start with. It's 12,288. So a sub 7, which is 7th term, is 12,288. So that wanted me to find two things, the rule and then the 7th term, and I found them. So after you get the rule, finding a term is easy. Okay? After you get the rule, plugging your n's in is easy. And just use your calculator because you're going to get some big numbers today.
Okay, so the r is how many numbers you want?
The r is your common ratio. So what you're multiplying times this number to get the next number every time is your common ratio. So that to get that, you do one of them divided by the one in front of it. Does that make sense? Mm-hmm. Okay. All right, let's do another example like this. We've got a series that starts 36, negative 12, 4. And then it continues on. That's what the dot, dot, dot means. Write the rule for the series Then find a sub 7 again. So we're still finding the 7th term again. So if we're finding the rule, remember we want to leave everything an n. So we use the formula again. A sub n equals a sub 1 times r to the n minus 1. So what two things do we have to know?
The beginning number.
The first term, which is 36. And what is r?
The ratio.
The common ratio. How do we get the common ratio?
Divide second by first.
And then, so it's negative 12 over 36. Reduce that to what? Negative 1/3. Y'all understand how I got r? Take two numbers beside each other, do the second divided by the first one. So my a sub 1 is my first term, so it's going to be 36. So my rule is going to be a sub n equals 36. My r is negative 1/3. And I don't know n, so I have to leave it n minus 1. Okay? So any questions on how we got the rule? So when you're writing the rule, you leave n's alone. So there's my rule. Okay? So when you write the rule, you plug everything except for n. Then it says, then find a sub 7, which means find the 7th term. So then you plug all of your n's in with a what? 7. Whatever that number is, that's what all your n's change to. So it's 36 times negative 1/3 to the 7 minus 1. Well, what is 7 minus 1? So a sub 7 equals 36 times negative 1/3 to the 6. I'm going to see if my calculator will let me type that straight in. I'm going to say 36 parentheses negative 1/3, which is negative 1 divided by 3, rooftop 6. You're getting a decimal?
Yeah.
Good. Now, did y'all get that in your calculator? Everybody get that number? All right, so how do we change an ugly decimal to a fraction? Math, enter. So you're going to hit the math button, which is under the alpha button, the colored button, and hit enter. And it reduces that fraction. It's not too bad. So the 7th term is 4 over 81. Well, let's talk about why that's a fraction. What's happening to these numbers as you go?
Positive, negative, positive, negative.
Okay.
Because of the it's being multiplied by a negative.
Right.
fraction.
So that's why they're alternating, because your common ratio is a negative 1/3. Okay. But also notice, are these numbers increasing or decreasing as you go? Decreasing. So that's why these numbers keep getting smaller, and that's why the 7th term is a fraction. Does that make sense? So if the numbers get bigger, then your 7th term ought to be bigger than your first term. Okay? But if your number is getting smaller, then that means your 7th term should be smaller than the rest of them. Does that make sense? So just use what you got to see how your answer makes sense to you. Okay. So that's how you write a rule if they give you an example of how the series goes. This one's going to be slightly more complicated. Well, I would. If it were my notes, I got it on my notes. Now, remember, we always need the common ratio and the beginning term, right? We got to know the starting term of the series, and we've got to know the common ratio, little r. Well, they didn't give me a list of the rate of the series. They just told me one term of this series, and it's not the first one, is it? No. They told me the 4th term in this series is 12. And the common ratio is r equals 2. write the rule. So remember, to write the rule, we need the starting term. So the first thing we have to do is find the first term. Because we can't write our rule unless we know the first term. Because remember, the rule is going to look like a sub n equals a sub 1 times r to the n minus 1. So we've got to know what a sub 1 is. So the way we find the first term is we use this same formula right here, except for we plug in the one we know. And the one we know is the fourth term. Right? So we're going to solve to get the first term by using the fourth term. So a sub 4 equals a sub 1. We don't know a sub 1. Times r. Did they tell me what r is?
Yes.
R is what? 2. Okay, so I'm going to use 2 there for r. To the n minus 1, but our n we said that they gave us is what? So that's going to be 4 minus 1. So then we simplify. Okay, we know a sub 4 equals 12. Right? So where we have a sub 4, we can plug in a 12. So 12 equals a sub 1. And 4 minus 1 is what?
3 to the third power.
Or 2 to the third power.
Yeah.
Times 2 to the third. Now what is 2 to the third power? 2 times 2 times 2. It's 8. So 12 equals a1 times 8. Now how do I get a sub 1 by itself?
Subtract 8.
Not subtract.
Divide by 8.
Yeah, it's multiplied, so we divide by 8. And we reduce that fraction. 12 divided by 8 is 3 over 2. 1.5, right? So now do I know my starting term?
Yes.
Do I know my little r?
Yes.
Then I can write the rule. That's the only two things you need to write the rule. Starting term and your common ratio. So you're just going to say a sub n equals, what is my starting term that I found? 3 over 2 times what's my r? 2 to the n minus 1. Because remember your rule, you leave all your n's alone. So there's your rule. Okay? So if they don't give you the first term, you have to find your first term. Okay, let's do another one just like that, where they don't give us the first term again. What term did they give us on this one?
The fifth.
This time they gave us the fifth term because they said a sub 5 equals 54. So we don't know what the first term is. We don't know any term in this series. We just know that the fifth one is 54. Okay? They also told us the common ratio is what? 3. So they want a rule for the nth term. So we're going to use a sub n equals a sub 1 times r to the n minus 1. Because that's the formula for a geometric series, and they told us it was geometric.
So 54 equals a sub 1 times 3.
To the,
Fifth minus 1.
which is the fourth, right? So I'm going to go ahead and I'm going to do one more step in there. So a to the fifth power, or a sub 5, sorry, not fifth power because it's down below, equals a sub 1 times r, and we said r was 3, to the n minus 1. Since we know the fifth term, we're going to use 5 minus 1. Okay, so I substitute all my n's with 5s. Hang on a second, my computer's wanting to shut down. No. Okay, so maybe it won't. So 5 minus 1 is 4. And a sub 5, the fifth term, is 54. So I'm going to substitute a 54 here. And where it says 3 to the 5 minus 1, I'm going to change that to 3 to the 4th power. Now, can y'all tell me what 3 to the 4th power is? It's 81. So 54 equals a sub 1 times 81. Now, how do we get a sub 1 by itself?
Divide it.
Divide both sides by 81. And I am going to get a fraction. Now let's type, we can type that in our calculator to reduce it. 54 divided by 81. Math, enter. 2/3. So my starting term is 2/3. So I know A1 now, and I also know my R. So I just leave my n's alone to write the rule. So A sub n equals times to the, very good. There's my rule for that one. So if you don't know what the starting term is, you do whichever one they give you and you substitute. Okay. So any question about writing a rule? All right. So now y'all remember how we did summations yesterday for a finite arithmetic series? Well, the last thing we have to do is a summation for a finite geometric series. And it has its own formula for this as well. So write down this formula. My class needs to have it memorized before tomorrow. So remember, a sum of a series, you just continually add one thing after the next. Whatever the sequence is, you're constantly adding the terms. Okay? A1, what is A1 again? What's A sub 1?
Beginning.
The beginning term in the series, the sequence. What's R? The common ratio. What does that mean? It's the number that's being done what every time? Multiplied or divided. Very good. So here's a new formula. All right, I'm going to write this over on that board over there in black so we can see it. I got a lot of red on my board. There's the beginning. And our calculator is going to help us a lot here. All right. Remember that big Greek letter yesterday? What's this Greek letter? Y'all remember what letter it was in the Greek alphabet? Sigma. Okay? This big looking, weird looking E is called a sigma. Okay? So it's the Greek letter for sigma, which means the sum of. Sum in math class means we do what operation?
Addition.
You're adding. Okay? So remember, this is my starting value. My first n. This is my last n. Okay? First n is 1. My last n is 16. This part is my rule. So if this part is my rule, isn't this A1 and this the R? Right? Right? So this is my first term of the series, or of the sequence, and this is my common ratio, right?
So you want us to make a series, right?
Well, no, we're going to find the sum of the series. So we're going to add all the numbers in the series between 1 and 16, the first term and the 16th term. So that's why they say finite, because math goes on forever. So if I didn't put a stopping point, I'm going to be adding numbers till infinity, right? So they would put an infinity symbol there. We're not doing that. We're not counting to infinity because we don't have time. We get up here. All right, so we're going to stop after the first term. You don't technically have to calculate all those numbers and add them. We're going to do this formula, which is that one I wrote in black on the board over there, which is highlighted in yellow right there. Okay, so you need to find your first term.
Which is 4. Yes, it is.
My first term, isn't this? So if this is the rule, this is my A1, isn't it? And this is the r, isn't it? Yeah. So my first term is 4. I got A1 there. And r is what? R is 3. And that's all I need. So, S sub n, so we're actually finding the sum up to 16. So my n is 16. Is going to equal A sub 1 times 1 minus r to the n over 1 minus r. Now let's fill those in.
16.
Equals what's A sub 1? 4 times 1 minus what's my r? 3 to the what's my n? 16. That's your highest. This number on top is your n. That's the highest number you're adding to over 1 minus 3.
So where does that I equal 1 plug in?
That's your initial term. That's your starting. I means initial. That means 1 is your first term. So yesterday we plugged in. Today we don't have to because our A sub 1 term is right here. It's in the rule. Right there. And easy to spot. So I'm saving you a step.
So 3 to 16.
So we're going to do our calculator. So I'm going to see if it'll let me type it straight in and get it correct. 1 minus. See, I got parentheses. Parentheses, 1 minus 3 raised to the 16. Close parentheses. Divided by parentheses. Can't we do 1 minus 3 in our heads?
No, we plug it in too.
No, we don't. What's 1? It should, but what's 1 minus 3? So divided by -2. Now that's little -2, not minus sign -2. If this number is going to be big, and then we multiply that, so that's my fraction part, times 4. Do what? I typed in the top, divided by 2, because or divided by -2, because 1 minus 3 is -2. And I got a big O number. And then I still got to multiply that number times 4. And then hit times 4. And I got 86,093,440. That's correct. Yours did the whole thing. So you can type it all straight in there. So why is that number so big? Well, it's a summation, right? Summation means I'm adding all the terms, and I'm multiplying all these terms by 3 every time, right? So the numbers are getting increasingly larger as they go on. I'm doing 16 terms of those and then adding them together. So no wonder it's a really big number, 86 million and something. Okay? So once you get to here, all you need, use your rule, A sub 1, there's your R. Plug A sub 1 in your R's in, type it in your calculator. Okay? Got it? Let's do another one. This is my last example, then you guys can work on your work. All right, so here is a series. We got the summation of from 1 to 8 terms. So this shouldn't be as big of a number, I don't think, because we're only going to terms 1 to 8. What's our A sub 1?
6.
Yeah. What's my R?
-2.
Good. So this whole thing is the rule, and we know A sub 1 and there's R. So remember our formula is S sub n equals A sub 1 times 1 minus R to the n.
Divided by 1 minus r.
Y'all, he's not that smart. It's on the board. I'm just kidding. He is that smart.
So
He is that smart. He's my student.
S.
So what's my highest? I'm going to 8 because that's what's on top of my sigma.
Equals
What's my, yep. And then 1 minus, what's my R?
+2.
No, can't put that because it's -2 to a power. Yeah, you can't put +2 here because you're raising it to a power first. So 8 over 1 minus negative 2. Now you can change the bottom to 1 plus 2 because it's not raised to a power. And 1 plus 2 equals what? 3. So when you type that one in your calculator, I'm just going to do the fraction and multiply times 6 at the end. I'm going to say parentheses 1 minus parentheses negative 2, close parentheses, raise it to the 8th, close parentheses, and then I already said the denominator was 3 divided by 3, and I'm getting negative 85, and then I multiply that times the outside number, which is 3. That's correct. So the sum up to 8 is going to be negative 510. It might be. Well, it's easier. It might be easier than yesterday because y'all are seeing sequences and series again. It's just a different formula, right? Yesterday's sequences and series was like brand new stuff and a lot of notation y'all weren't used to yet. But after y'all seen it for a day and practiced it last night, hopefully, then today it's a little bit more fresh, just a different formula. Does that make sense? Are y'all good with putting that in your calculator? Use your parentheses. Say I use parentheses here because if I don't put that negative 2 in this parentheses, it's going to tell me that's a negative number and completely mess up my fraction. So you have to put a negative in parentheses. And then I use the whole parentheses around my whole numerator and then divide it by 3 and then multiply it by 6. There is ways you can type it all straight in using lots of parentheses, but to me that gets more confusing. Mm-hmm. What do you mean plus?
You know, when you have a minus in the number with a negative, it becomes positive, right?
Okay. Yes, but right here, order of operations says you have to raise the powers before you add and subtract. So you can't just change that to a plus, because Dylan said the same thing. You can't just change that to a plus because you have to raise negative 2 to a power before you can change the sign. Does that make sense?
You can get the power before you.
Yes. So you could in your calculator do this power, and what it's going to be a positive anyway, right? Because if you raise it to an even exponent, it's going to change the number to a positive. So it's going to be a positive 32, right? Negative 2 to the 8th power. Not to the 8th, that's to the 5th power. What's negative 2 to the 8th power?
2, negative 256.
No, it should be a positive.
Negative 2 to the 8th is negative.
Because you put parentheses around it. Okay. Anything raised to an even exponent will be a positive. That's one of those things your calculator lies to you about. Yeah. Calculators lie if you don't put parentheses around your negatives and you're raising it to an even exponent. All right. So, Mr. Ants did not leave you. I'm going to stop my recording. Goodbye.